Assalamualaikum and good morning. We are from Group 4. We will present about our Manova project entitled Motion of Water Bottle on Sliding Surface. Okay, my name is Afifah Binti Arshad. My matrix number is 198776.
I'm Renishaa Ragupathy with matrix number 198239.
My name is Joo Xian and then my matrix number is 199034.
My name is Mohamad Aliff Ikhmal bin Zulkafli. My matrix number 198978.
My name is Khairul Bin Abdullah with matrix number 196826.
So the main objective of this project is to determine the time taken and the distance traveled by a water bottle with different volume of water to stop after sliding down on a surface with different sliding height and presence of air resistance with different strength. Next. So the material and apparatus needed for this experiment is a water bottle, wood plank, bricks, fan, stopwatch, measuring tape and water. So to set up the experiment, place the bricks at one end and put the wood plank on top. Place the fan facing the setup. Fill up a water bottle with 200 ml of water and add in another 200 ml of water when the experiment need to use 400 ml of water. Now I'll pass it to Joo Xian.
Thanks, Renishaa. Now I'm going to explain about the experiment procedure. And then we have two experiments, which is the experiment 1 and experiment 2. For experiment 1, our responding variable is the time taken. For experiment 2, the responding variable is the distance. So let's look at the experiment 1. Our first step is place the water bottle with 200 ml of water at one end of the wood with sliding height of 5 cm. The second step is place a fan facing the setup with a fan speed of 1. The third step is record the time taken for the water bottle to stop after rolling down the wood. The fourth step is repeat the experiment with a volume of 200 ml and changing sliding height of 10 cm and fan speed of 1. And then we record the time taken. The fifth step is repeat the experiment with a volume of water of 200 ml with sliding height of 5 cm and a fan speed of 2. And then record the time taken. And then the following step is repeat the experiment with a volume of water of 200 ml with a sliding height of 10 cm and a fan speed of 2. And then we record the time taken. And then the last step is repeat step 1 to 6 with volume of water of 400 ml. And then next, for experiment 2, the responding variable is the distance. And then basically the steps are the same. Just from the step 4, we change from the recording the time taken to measure and record the distance travel. That's all from me. Then later I will pass the presentation to Khairul, which he will discuss about the Manova calculation. Thank you.
Okay. Thank you, Joo Xian. Okay, next is manual calculations. Since doctor have mentioned that we can use any open source other than Excel or MATLAB, so we decided to use statistical package for social sciences, which is SPSS software. So this is the data obtained from the experiment. This is our raw data. We got it from the experiment we conducted. So first table is the time taken. The time taken for the bottle to slide down from the sliding surface. So this is the first table of the time taken for the bottle to sliding surface. So the height we measure first at volume 200 ml. We measure at the height of 5 centimeter and 10 centimeter. Then the next step is by changing the volume to 400 ml. Then at 5 centimeter and 10 centimeter of height. Then we adjust the fan speed from 1 to 2. Then we take all the readings. Okay, next the raw data table for second experiment, which is we measure the distance traveled from the bottle. So we measure the distance traveled at the volume of 200 also, 200 and 400 ml, and at the height of 5 and 10 centimeter by changing the speed of the fan at 1 and 2. Next, I'll pass it to Aliff. Aliff.
Okay, this is result for the descriptive statistic, which is the first experiment which is time taken. So the table consists of volume, which is in ml, heat is in cm, fan levels, and from the result. Before we get the descriptive statistic, we we are selecting post-hook test for 3 of the tests, which is fan speed, volume, and height, and then select overall and then press OK. So the results come up with this one. So this table consists two of statistic and standard error of mean and standard deviation and variation of the statistic. So next, this is the table, also the same for the time taken, but this one is for distance travel. So we can see that we get the results by taking the overall test and get the mean for the statistic and standard error, and standard deviation for statistic and variance for statistic. So next, I will pass to Khairul.
Thank you, Aliff. So this is the graph depicts the time taken of a water bottle to stop after rolling down on a sliding surface. So as we can see, the first graph shows that the estimated marginal means of time taken for a bottle to roll down on a surface at height of 5 centimeter, and the second graph depicts that the estimated marginal means of time taken at the height of 10 centimeter. So yeah. Next, Aliff.
Okay, this one is also the same for the graph, but this one is for the experiment 2, which is distance traveled by a water bottle to stop after rolling down on the surface. So the graph involving three of the depending variable, which is fan speed, volume, and height. So this is the graph for the estimated marginal means versus fan speed. We can see that for the left side graph, we can see that there is a red line and the blue line uh, uh, involving the experiment, and for the right side of the graph, you can see also the red line and the blue line. Red line at the bottom, at the top, and the blue line at the bottom space. Okay. Okay, I will pass to Afifah.
Okay, for the conclusion, the time taken for the water bottle to stop rolling and the distance traveled by water bottle, which is the manipulated variable affected by the volume of water, height of sliding surface, and fan speed, which is responding variable. Based on the data collected for experiment 1, we can conclude that the bottle with 200 ml of water, sliding height at 5 cm and fan speed at 2, has the highest time taken for water bottle to stop after rolling down. Meanwhile, for experiment 2, we can conclude that the bottle with 400 ml of water, sliding height at 10 cm and fan speed at 1, has the highest distance traveled by the water bottle after rolling. For the descriptive statistic, the treatment that consists of 200 ml of water, 5 cm sliding height, and fan speed of 2, shown the highest mean statistic, which is 11.1 seconds. Next, there is also an interaction between volume of water, height of sliding surface, and fan speed on the distance travelled by the water bottle, which is consists of 400 ml of water, 10 cm sliding height, and fan speed at 1, shown the highest mean statistic, which is 284.5 cm. That's all from us. Thank you.